So first step, our step number 1 is to label our triangles. When I draw an arrow to the opposite side of that right triangle, that indicates that that's the hypotenuse. That indicates that's the hypotenuse. Well, we need to do that because, for an example, that flagpole question, we need to figure out where the hypotenuse is. They're not going to give us a triangle. Then we need to identify where my theta and my right triangle or right angle, that's my adjacent. That's my adjacent leg. Adjacent, adjacent, adjacent. And I did say yesterday that if you learned it a different way, do it your way. But I'm just teaching it how I know it. And my last leg that's left over is my opposite leg. Okay, so now I have it labeled. I'm going to move on to this part. Now this part here is pretty easy cheesy. A squared plus B squared equals C squared. That's it. Pythagorean. Like you couldn't get any easier than that. The other thing that I want to mention out loud to everybody is we have to use the units that they gave us. So if they gave us centimeters, well, then let's do that in centimeters, okay? And if they gave it to us in meters, well, then let's do that in meters then. All righty, so let's go ahead. I did this fairly quickly. I think I did 6 squared plus 3 squared equals C squared, or I got 45, but don't forget we need to square root it. I know I'm doing it super fast, but I just want to get through the notes because they are a little difficult. Ooh, that works good to me. To see them, see them, see them. What'd you get on this one then?
Oh, on this one, I did 5 squared, which is 25, and 12 squared, which is 144, which equals to 169.
169.
Squared, which is 13.
Sam, thank you, thank you. I just want to make sure because I just did it this morning, and this first period they saw that my math was a little off. So then I just wanted to, let's see, 5 times 5 is 25. 2 times 2 is 4. 25 plus 4 is 29. Second, 29. 5.38 meters, give or take, something like that. But there's a problem, and here's my problem. I so screwed up. So double check it and see if y'all notice this. This is actually my right angle, and that's actually my hypotenuse. How the heck did I make a triangle with my hypotenuse of a 2? I so screwed that up. So I'm going to have to fix that for next year. Is that what y'all were going to say? Yeah, right? Oh, that is my right triangle. That's my hypotenuse. So that's actually my C square. So I don't know if y'all noticed it, but that was a mistake that I caught this morning that I need to fix for next school year. Now, the next question, though, is not a mistake. I hope you caught this next one, or if anything, draw it out. So here's what it says over here for this next one. There's a ladder leaning against the side of a house. Okay, here's a house. There's a ladder leaning against it. Let me draw this ladder out. So what I said yesterday, when in doubt, draw it out. And that's going to be very helpful for this situation. It says that the house is 10 meters tall. Dang. 10 meters tall. So that's where I'm going to label the 10 meters. Then it tells me that the base of the ladder is 3 meters from the house, meaning this right here is 3 meters. The question is, how tall is this ladder? Well, it looks like to me, I just created a right triangle. And if I created a right triangle, I can go ahead and label this as my hypotenuse. So hopefully you did catch this, that it is an A squared plus B squared equals C squared. And my hypotenuse, I did not screw this one up, is the C squared. So that would be 3 squared plus 10 squared equals C squared. 9 plus 100 equals 109. Square root that number. And then hopefully here you got my C of 10.44 meters, which does come out to be larger than 10 and larger than 3. So that's good. My C should always be, or my hypotenuse should be larger. But this one, okay. This is where we're getting a little tricky. I know it was part of the homework. I was hoping you tried it. That's it. Miss Munson, I ain't gonna lie, I didn't even try it. Okay, fine, you didn't try it. Do it now, okay? Draw out the picture, show your work. This is not an easy question, but this is what we're getting to. We have to be able to do this. It says from a horizontal distance. Oh, horizontal distance of 80 meters. Isn't this horizontal? There you go. Horizontal distance of 80 meters. The angle of elevation to the top of a flagpole is 18 degrees. Oh, okay. Here's the flagpole. All right, I got my flagpole. And if the horizontal distance is 80 meters, the top of the flagpole is 18 degrees. What are they trying to say to me, Miss Munson? This person is sitting here, they're looking at the top of the flagpole, and when they're looking this direction, this right here has a theta of 18 degrees. That's what they're telling me. Horizontal distance of 80 meters. When I look at the top of the flagpole up there, this theta right here is 18 degrees. Okay, what's the actual question asking me? Calculate the height of the flagpole, meaning what is that distance? Oh, whoa. Okay, what I do see here is a right triangle. That's my hypotenuse. This is my theta. This is my right angle. That's my adjacent. That's my opposite leg. Okay, remember that easy labeling? It's going to come back to haunt us because I try to teach us step by step. Okay, now let's look what we're doing. We're needing this leg right here. I don't know that height, but they did give me this info right here. This actually is a SOHCAHTOA problem. SOHCAHTOA. I have the A, check. I have the O that I'm looking for. The A and O is the TOA. Look, I'm looking for the O leg, the opposite, the height of the flagpole. Okay? I'm going to use the TOA equation. The TOA equation from our notes is the tan of the theta equals the opposite divided by adjacent. We have to be able to do this next week on the quiz. And so we are going to practice this for homework over the weekend or on Monday. And so what we're going to do here is the tan of the theta. Oh, wait a minute. I have that theta. Here it is right here, 18 degrees. Let me fix that real quick. The tan of 18 degrees. Do I have the O? No. I have the A, 80. And remember what I told you. If you type in those tans or cosine or sine, if you get a negative, wrong. You're in the wrong mode. So let's go ahead and let's keep going here. We are going to go ahead and we're going to turn on our calculator. I'm going to say, oh, tan of 18. I checked it earlier this morning. I'm in degree mode. Oh, maybe I'm not in degree mode. Let's look. I am in degree mode. Okay, clear. Tan of 18 degrees. Okay, there it is. That's what it is. 0.325 equals O over 80. Multiply this side by 80, cancel, multiply this side by 80. I get an O, or the height of the flagpole, 25.99 meters. Am I off? Give it to me. Yes. still got 25.99, right? Okay, no, that's perfectly good. I will show you one more thing on in a moment of how to do the triangle for
Wait,
that.
so if we round it up, will it be wrong?
Oh, no, 30 is perfect. 30 is good. If you put 30.
Yeah, I put 26. Yeah, I put 26.
Oh, I'm so sorry. 26. Forgive me. I don't know why I thought 30. What happened? Give it to me, Josiah.
That's what.
Okay. Gotcha. You rounded up to 30. I said 30 again. Let's say 26. Oh, I just marked it down on a pencil every time you laugh at me. And we're gonna, no, we'll get him back.
I don't mind being like.
That's okay. Me and you will, every time he laughs at us, we're gonna start documenting it. Okay, so the opposite leg or the height is 26 meters. Okay, smarty pants, not a problem. Then give it to me, Shelby. What's the sine of 25 degrees? The cosine. The tan. Okay.
Wait, what? No? Yeah. Oh, there we go. Yep.
Well, that's what the answer is, yeah.
Exactly.
Yes.
Can you upload your syllabus online?
Again,
Can you upload your syllabus online?
on D2L, so that way you can have a regular copy and it, because it got submitted as a homework?
Yeah.
Yes, I absolutely could. I can do that for everybody. I've got a small to-do list over here that I was writing myself. I'll add that here too. You-
What's the name of our book site again?
ck12.org. ck12.org. Yes, no, thank you for letting me know. I have a little to-do list that I'm not leaving till I get that done. Here's what we did say though earlier today, and you might have missed it, so let me say it again since you're here, Carlos. This is homework 3. The homework 3. We did not do this, but now we're gonna do this for Tuesday, okay? And I pushed back all of the other dates, and I'll go ahead and change it on the calendar. There we go, change physics calendar. All right, gotcha. Move that out the way. I have to go over that practice problem more detail because that's what your homework is going to cover. So in that situation, let's take a glance at here because that's what we're gathering. We're going to cover this one page and one problem on the other side. That's it for today, and that gives us enough time. We should get out plenty of time, and I know which will be good because you've got to go get some food and go to play. So, gotta eat, gotta hydrate. Page 10 out of 25? Yes, ma'am. So let's take a glance. This is starting to go into what we call SOHCAHTOA, right? The sine, the cosine, and the tan. And so let's take a glance. We're gonna do a couple of these problems. We're gonna do the bottom one, then we're gonna flip it over for one question on the other side. That is it today.
Is this like basically what our quiz is going to be, SOHCAHTOA?
SOHCAHTOA, Pythagorean, yep. And being able to label this, like the homework question. Remember how the homework had those blanks?
Oh, yeah.
And you were able to label, that was easy, yeah, definitely. So that was a good call. Our quiz will be covering SOHCAHTOA, Pythagorean, and when that you tossed a ball into the air. There-
So not like the problem?
Well, yes, this SOHCAHTOA as in this physics. This is SOHCAHTOA right here. This is SOHCAHTOA. But this is still, remember how I told you I like to baby step us? This is another step. So first thing is SOHCAHTOA. There are the 3 problems or equations that you're going to use. For an example, over here, I need to label my triangle. So let's do that. If this is my right angle, that's my hypotenuse. If this is my theta and my right angle, there goes my adjacent leg and my opposite leg, okay? Hypotenuse, opposite, adjacent leg. So there they are. Okay. Now I need to, and this is, I like to highlight it. This is just me. This is the leg that they gave me, and I want to highlight the leg that I'm using or need to find. Does that make sense? It helps me because y'all see how I mess up all the time. I need to help organize my brain. So what equation am I going to use? if I have an H and I'm looking for an O, who has the HO with it? The sign, right? The sign equation is the O and H. So the sign of the theta equals the O divided by H in that order, okay? Now let's go ahead and fill in the blanks, or let's work it out. The sine of 35 degrees equals the O leg, I do not know, and the H leg is 16, remember, centimeters. So,
Wait, so how do you know that it's a sign?
yes, because I highlighted this leg that I have, which is H, and this leg is O, and this has O and H.
Oh, okay.
Mm-hmm. Yeah. I know, that's so, I like this SOHCAHTOA because it helps me, like, I can see those two, and those are the two there. Okay? I'm going to go ahead, if that's okay with everyone, I'm going to highlight, again, I have to do this for myself, the A and H and the OA. There we go. So let's go ahead and fill this in. Josiah is going to give us the answer. While he's working it out, I'm going to work it out up here. Multiply by 16, multiply by 16. The sine of 35, just in case, unless y'all don't trust Josiah, but 16 times, I don't trust him, that's why I'm working it out here. Shh. Golly. Giving all the answers away. What'd you get?
9.12.
I don't, maybe we went different digits. I got 9.17. So I got 9.17, 9.12, 9.17, you know, 9.18. Oh yeah, because if you round it up, I mean, give or take. I will look to see if you did the equation right or wrong. Let's do it again. Yes, sir.
So when I did it, I use 0.57 instead of just using that whole number.
Nope, you're perfectly good. That's the reason why yours rounded a little different than ours. You are perfectly good. I'm going to see your work on the quiz day, and I'm going to give you full credit. Mm-hmm. Yes.
It's all right if we're a little bit off, like by a point.
Oh, yeah, no, you are a little bit off. It's okay.
Because some teachers, like,
Don't like it when you're a little off? Oh, it's okay. I understand. That's who you are. Gotcha.
thank you.
Yes. That's what he's just said. Yeah, not a problem. Let's do this again. Let's do Shelby. B, C, B or D? No C.
No, see.
B. Okay, let's do B. After that, then we're going to jump down to the bottom page question. Here we go. We're going to do B. What is step number 1? Label your triangle. So come over here. H. Theta and right angle. A. O. Okay. So now, what is it? Trenton? What? So, a ka or a toa? So. Why is that? Because we have the H and we're looking for the O. There you go. So sine of the theta is the O over the H, or the sine of 60 degrees equals, I don't know that O, I do know the H of 8, but take a glance, kilometers. Don't let those units throw you off. Multiply this side by 8. Multiply this side by 8. Okay, so the sine of 60 degrees, I've got it at 0.866. Multiply that by 8. Again, you may round a little differently. I have this leg, the opposite leg of 6.9. I'm going to round it to 3 kilometers. Not bad. I hope this is pretty easy. I really, in my gut, hope that you've done this math before and you may have forgot and now it's coming back to you. That's what my hope is. But go to the.
Geometry.
Mm-hmm.
We didn't do nothing with geometry, Jordan. You know that.
Yes, I did. I did something. I used my resources.
Oh, I didn't go.
No, really.
My geometry teacher was good.
My geometry teacher just
Mine
wants
was
to
not.
use our resources.
He was nonchalant.
Oh. Oh.
He was, yeah, well, he was kind of weird.
Oh.
Wait, is this our last question?
Nope. This one and one more.
I think so.
So, yeah, we have this question and then remember the hummingbird on the other side.
Okay.
That's it. Just two more questions. Because on the quiz, this is not how I'm going to give it to you on the quiz. No, that's baby. Now we're ready for high school big. We're starting college physics.
I'm not ready.
Yes, you are. We're going to do it together. So let's do, not quiz though. Not quiz. I'm sure I can. Not quiz or test. But let's get ready. Archaeologist. There's an archaeologist who wants to climb this pyramid. Okay? If the pyramid's height is 140 and its width is 230, wait a minute, Kenneth, what am I going to do with the base of this triangle? Am I going to leave it 230? This triangle right here, he's about to climb this triangle. Am I going to leave it 230? Nope. What am I going to do? Cut it in half. I agree.
Cut it in half.
Cut it in half.
115.
The height, the tour guide told me it's 140 meters. Now, this archaeologist, who's down here at the bottom, is about to walk up to the top of this pyramid. I need us to pay attention to this part right here. I thought I said it yesterday, and I may not have said it yesterday in class for lecture, so I'm saying it right now. When I draw vector arrows that I am looking for, the tail end of that vector arrow is the theta. One more time. When I'm drawing my vector arrows, I draw my vector arrows or my object is traveling or I'm looking for in dashes. That's for me to recognize that's the one that I'm looking for. The tail end of the arrow is your theta. We got that. I said it twice. You got it in your head now. Now let me finish reading it. What is the magnitude and direction? Please, in your notes right now, write this in because I'm not going to be there this weekend. I've got plans Saturday and Sunday, okay? Unless you want to meet me at church. But magnitude, Galveston.
Oh, that's too far.
Oh.
The one on Harborside? I mean, not Harborside.
Magnitude is numbers. Hold on, you're getting me blanked over here. And direction is a theta in physics. One more time. When they ask for magnitude and direction, that is two answers on your quiz/test day. If you don't give me both parts, then you're going to miss 1x, okay? Magnitude, I've already used that word multiple times. It means numbers in physics. But wait a minute, do we write a number by itself? No, we add an SI unit at the end, right? Direction in physics means a theta, okay? For an example, those of us, let's say you want to be a pilot. Now, did you know that if you're driving a ship or a boat, those are also called pilots, not just driving an airplane, okay? They make super great money, okay?
That's what I want to do.
Oh, there you go. You gotta go. Here you go. Go to A&M Galveston.
I'm gonna go to A&M, guys, 2 years after I go play football.
Yep. Yep. It's good money. It really is good money. So they're also called pilots. If you're a pilot, then you need to know your directions in thetas and degrees. They use physics. Okay? Yes, a lot of physics. So let's pay attention here.
Dang,
If
I
the
might not be a captain, man.
Oh.
I do got a lot of physics, so.
You could be the guy who brings people their food.
Hey, they make money.
Yeah.
For real.
Right? I'm all about that. So here we go. What am I looking for? I'm looking for two things. I'm looking for this arrow, which is the number, and I'm looking for this theta, which is the direction. Okay? I'm going to have to do two parts to this problem. Part number one, let's go ahead and let's do either the leg. How would I solve for the leg? What equation would I use? What equation would I use for this leg? Pythagorean. And for this theta, which equation would I use? SOHCAHTOA. Okay? So do you see how I started and did parts? But now I'm bringing all those parts together in one math question. So here we go. I'm going to go ahead and I'm going to say part one, SOHCAHTOA. That's this. Part two is Pythagorean, a squared plus b squared equals c squared, which is this. Okay? So this part right here is this. This part right here, this leg, bless you, is this. Hopefully that helps you, because I'm not going to be there with you at home this weekend. So if I, this and this. Now let's go ahead and do this. Oh, wait a minute. Josiah, I have to label my triangle. I'm about to ask you if it's ka or toa. So start using your brain and start thinking about it. This is my hypotenuse. If this is my theta, and that's my right angle, this is my adjacent. Do you see how teaching you how to label it was important? And here's my opposite. So Josiah, get ready. I have the O leg and I have the A leg. Which part of the SOHCAHTOA am I going to use? The TOA. I agree with him. The O and the A. So,
How do you know which one, like,
mm-hmm.
how do you know which ones that you're gonna highlight, whatever one's on the?
Good call. What do I have? I have this side and this side who so happen to be the O and the A. So I highlighted, for this situation, I highlighted what I have.
So we're doing TOA?
So we're doing TOA, which is O and A. So the tan of the theta equals the O over the A. Or do I have the tan? No, I'm looking for it. The tan equals 140 over the A is 115. I'm about to, Kenneth, do you have your calculator? Your graphing? Dang it. That's all right. I'm keeping the words in my head. What is 140 divided by 115? That's got to be a decimal point. 1.21? 0.21. 1.21. Okay. Now, stop for a moment. In your mind, wouldn't this be 90 degrees? And half of 90 is 45 degrees? And half of 45 is like 23.5 degrees, like this? Look at 23.5 degrees. Could this, look at this archaeologist up there. Could he walk up a 1.21 degree angle, which is like this small, and make it up to a top of a pyramid? No, that's not my answer. When I am looking, and pay attention, when I am looking for the theta, because this is my unknown, I don't know it. This is my unknown, I need to do the opposite of theta. For an example, the opposite of square is square root. The opposite of tan is what we call in math the inverse of tan. Find the inverse of tan button. It's where? It's right above. There you go. So you're going to hit second key. You're going to hit second key, and you're going to hit the tan button, and it looks like that. Now type in 1.21, close parentheses. There you go. Your theta is 50.43 degrees is my correct unit. If you do not add degrees, minus 2 points. That is only half of my answer. The other half is Pythagorean. So let's do that. 140 squared plus 115 squared equals c squared. You can do that on your own, right? 140 squared is 19600 plus 115 squared is 13225. Add those two numbers together. 32825 equals c squared. That's not my answer. Square root it. And double check me. 32825. C is about 181.18. Oh, wait a minute. That's a meter. So this question had 2 parts.
Heck yeah.
Do we need to do another one, or do you feel like you're comfortable for the homework?
I'm pretty comfortable.
Okay,